Look at this, just a bent little ring of metal. Maybe cost 10 cents, or better known as this, because it's just stuck up of 3 of them. So maybe they cost 10 cents per each. And if you get it wrong, it can destroy a bearing that worth hundreds of dollars. This is a wave washer. And today we are breaking down exactly what does it do, why it's shaped like this, how to design one, and more importantly, is the one mistake that ruins them more than anything else. Welcome to the component file. Every episode, we grab a mechanical part, something small, something you've probably seen hundreds of times and never thought about. And we crack it open, what it does, why it exists, how to actually use it. So first up, the wave washer, which is this part right here. A stack up of 3 wave washers. So my name is Jamal. I spent the last 10 years designing machines and mechanical parts for a living. Cars, aerospace, industrial equipment, all of it. This channel is where I show you how mechanical design actually works in real world, not the textbook version. So basically, I will take you through how to design in SolidWorks and how does special purpose machines actually work and how to design them. And if you are chasing the CSWA or CSWP certification, this is your right channel. New video every week. Let's get into it. So what actually is this thing? Simple answer, it's a spring. That's it. Normally, when you think of a spring, you picture a coil, right? It's like slinky. This does the same job basically, but instead of coiling a metal, you bend it into wave. Same spring action, way less space needed. So basically, that's the thing that differentiates the wave washers from real springs. And of course, the cost is way less because you get this from stamping. So you can stamp literally 60 pieces per minute or even more, where coiling takes more time, hence more expensive. Next question would be, why does this even exist? Think about a machine you built. Nothing is ever the exact perfect size. Every part has a little bit of tolerance, a little bit of wiggle room, and when you stack a bunch of parts together, all those tiny gaps adds up. Now you've got a play in your assembly that you didn't plan for. And play means rattling, vibration, and even pressure. In bearings, it means the balls inside start skidding instead of rolling smoothly, and that bearing is not going to last long. So you need something to soak up the extra gap. Something that pushes back gently and keeps everything snug. That's the whole job of this little washer. Where do you actually run into these in real life? 3 places. Inside the bearing, keeping them snug so they don't rattle. Think electrical motors, pump inside electrical connectors, keeping the contact pressure steady even after vibration and wear. And inside clutches, of course, and gear systems, keeping everything pressed together evenly. Quick pause here, because this next part actually matters. Figuring out exactly how much of that gap you are dealing with means doing what's called tolerance stack up. Basically, adding up all the little size variation in your assembly. Most engineers either skip this step or rush it, and it comes back to bite them later. This is literally one of the things I walk through step by step in Machine Design Verification Toolkit I built. Link down below if you want to check it out. Truth is, in real world, you almost never build the wave washer from scratch. You pick one out of a catalog, it's cheap, it's proven, why reinvent it? But you should still know how to model one properly, so it sits right in your assembly and you actually understand what you are buying. So here is how to design it. I will take you through the steps I have followed step by step. So basically, we started with the ring. So basically, that's the ring. External diameter is 20, internal is 16. And then we've drawn a sketch right here so we can deform our ring like this, so you can see these deformations are coming up. And then of course we doubled it and we turned it, and then we added another one, so just to make us a stack of rings. So let's actually design them right now. So click on new, click on parts, and then click on OK. Once you're here, select from face and then just go to create the first ring and then the second ring. So we said that the external is 20. Feel free to go to a catalog and actually design one by yourself without using my dimensions. So basically I picked one up from Musumi and tried to design it. So the thickness is 0.15. They are really thin, but they have pretty good spring load. And now let's just create the sketch here. So basically the sketch is another circle, and this circle is actually for construction, and then you add 3 points, one here, and the other one right here. And then let's just go to center line. Just click it like this. Let's just delete this one. And right here, let's just add up the angle between each one. So it's 120 because it's 360 all around the circle. Right, we're good. Now let's just add this dimension, which is 18. Between 16 and 20, there is 18. So basically that's it. Let's just leave the sketch, and here let's just go to deform. Just click on deform, and of course we want normal deform, not free one. We don't want to have a free one. Just click on this point right here, and then just go to parameters. It should be 2 in height, 9 of course in width, and just pick this one up, the first one. Right, so once you've done that, just go to the second point again, click on deform, search, second point, same thing, and keep it like this. And then let's go to the third one, same thing, click on this one, click on OK, and there you have it. Now let's just go ahead and hide this sketch because we don't need it anymore. All right, now it's hidden. Let's just go and apply material. So basically these guys are made out of stainless steel. So let's just go to stainless steel, which is this one. It's 1405, so it's made out of these. You can of course choose any material you want, but mostly you find them either in metal with black oxide and stainless steel. So let's just go to pattern. Let's select this face right here, and of course we will be multiplying the body, and the distance here should be 2.15. That's the distance, and of course we just want 2. So here you should go to this second part and just turn it. To do that, you go to data migration and then move faces or bodies, and then just go to rotate. And of course here you should select a body, which is this one. Once you're here, you can just turn it a little bit. So here it's doing a 300 degrees, means 60 degrees. So there you have it. Of course you don't want to copy, you just want a real one. And there we have it. Now to multiply, you just go to the first one again and go to feature. Just click on linear parent. And of course you can just select this face right here. You don't want to move a feature, you just want a body. So in this case it's this body right here. And of course we will be doing double this. So to do double this, just click on doubled by 2. Click on OK. And there you have a stack up of 3 wave washers. So that's basically how you design one. So now let's move on to one of the most important parts of this video, is where people get it wrong. Engineers most of the time size this thing for the perfect case, means nominal dimension, everything exactly on paper. But parts in real world don't come out perfect. They drift toward one end of the tolerance range or the other. And when they drift the wrong way, the washer gets squeezed further than you planned, sometimes all the way flat. And once it's flat, it's dead. It's not spring anymore. It's just a flat piece of metal doing nothing. And that's the exact moment your bearing starts rattling. One more mistake worth knowing: don't let this thing sit against a rough or uneven surface. It needs a hard, flat surface on both sides, or the force goes uneven around the ring and you get an unpredictable result, even if you picked the perfect washer. So that's it for mistakes that gets engineered most of the time. A quick recap here: wave washers. It's a spring that soaks up leftover gaps in your assembly using way less space than a coil spring. Pick it based on the force curve from manufacturer. Size it for worst case gap, not the perfect case gap, and never let it squeeze flat. So basically that's it for the wave washer. If you are interested in getting all this documented in one simplified document, I have actually prepared one Word document along with a Canvas document that would help you remember what does this washer do and how to actually use it. You will find it down in the description if you're interested at it. So that's it for the washer. So next time we will be cracking open another mechanical component. Of course, if you need to crack open any of mechanical components, feel free to write it down in the comments. Subscribe so you don't miss any of it. If you want the toolkit I mentioned, it's in the link right below this video. Again, thanks for watching and see you in the next one.